look at this problem. Find the derivative for y equals all of that. Now this doesn't have a base of x raised to the power of x in any way, but it does have product rule required in the numerator, and the whole thing, since it's a fraction, would require the quotient rule. So this fits the second reason for having logarithmic differentiation, a complicated product or quotient rule. So let's do the problem. And we can, in general, follow our steps. We're going to have to recall some other rules of natural logs. We'll take a look at those as we encounter them. The log of both sides. Natural log of y equals the natural log. I'm just going to write all this. I'm going to get rid of that square root symbol. X times x squared plus 1 to the 1/2 power all over x plus 1 to the 2/3 power. Okay. Now I have to do something with this right hand side. Let's recall a couple rules of natural logs. If I have the natural log of a divided by b, I could rewrite that as the subtraction problem. This is natural log of a minus natural log of b. Likewise, if I have natural log of, let's say, c times d, I can rewrite that. I can change the multiplication into an addition. This is natural log of c plus natural log of d. You need to remember these basic rules so that when you have a problem like this, you can clean it up, write it in an easier format. And let's rewrite the right-hand side. I have in the numerator, these two functions are separated by multiplication, so I'm going to use this rule. And then the numerator and the denominator obviously is a quotient, so I'm going to separate it using this rule. So let's do the numerator first. I've got natural log of x plus natural log of x squared plus 1 to the 1/2 power minus natural log of x plus 1 to the 2/3 power. So it helps me out. Now I have the natural log, just 4 different terms of natural log, and this should be easy from here. It's going to take up a lot of space, that's why we have the whole page. But still, let's clean up, or let's move some exponents down. Move that in front, we're going to move that in front. Clean it up a little. Natural log of x plus 1/2 natural log of x squared plus 1 minus 2/3 natural log of x plus 1. Okay, all I did was move the exponents there. Now, my next step in logarithmic differentiation is to take the derivative of both sides. I'm going to write it like that. That's the derivative of this whole thing. So let's do it. Derivative of the left, 1 over y times y prime. Derivative of natural log is just 1 over x. Plus, constant in front comes along for the ride. So 1/2 times the derivative of natural log of that, all that, 1 over u, so 1 over x squared plus 1, times the derivative of u, which is 2x. That takes care of that one. Minus 2/3 comes along for the ride. The derivative of natural log of this stuff is 1 over x plus 1 times the derivative of x plus 1, which is just 1. Alright, let's clean that up on the right hand side. 1 over x doesn't need any cleaning. Let's see, those 2's cancel. So it's just x over x squared plus 1 minus, nothing cancels, but I'm going to rearrange it how it's written, 2 over 3 times x plus 1. Okay, well, now that I have this on the right hand side, I kind of have a lot going on. The best bet here would be to make a common denominator. So that's what I'm going to do. It takes a little bit of algebraic work, but it's worth it. I'm going to leave the left-hand side as is right now. Now, my common denominator, what's it going to be? It's going to be x times x squared plus 1 times 3 times x plus 1. Right? Everything together. So in my first piece, I need to, in order to make this into the common denominator, I need to multiply by this denominator and that denominator. So that's going to give me x squared plus 1 times 3 times x plus 1, all times the 1 that was originally there. That's my first piece. This term, to make this common denominator, I have the x from the original fraction. I need to multiply by this x. I need to multiply by this denominator, 3 times x plus 1. For the third piece, I'm going to go ahead and put my minus sign there. I've got a 2 up top already. For this one, I need this denominator and that denominator. So x is the first denominator I need. X squared plus 1 is the second. Just making a common denominator. Let's clean it up. I'm actually going to have to multiply through some of these things here, so let's see. X squared plus 1 times 3x plus 3 plus 3x squared times x plus 1 minus 2x times x squared plus 1 all over this common denominator. I'm going to clean up the common denominator. Let's put the 3x in front. X squared plus 1, x plus 1. Don't multiply through in the denominator. I do need to multiply through in the numerator because I have to see if anything can be simplified. So here we go. We're going to FOIL this first piece. 3x cubed plus 3x squared plus 3x plus 3. Let's distribute this next piece. 3x cubed plus 3x squared. We'll distribute this along with the negative sign. Minus 2x cubed minus 2x all over that common denominator. I need to combine like terms. Let's see, I got 3x cubed and 3x cubed. That's 6 minus 2, 4x cubed. 3x squared, 6x squared. Three x minus 2x gives me just plus x. And then there's a plus 3. All over, same denominator. Okay. That's all I'm going to do on the right hand side at this point. I need the next step of logarithmic differentiation is to solve for y prime. So I'm going to multiply by y on both sides. So I get y prime equals, and I'm going to substitute in what y was. X times the square root of x squared plus 1 over x plus 1 to the 2/3 power times all of this. Ooh. Anything cancel? Oh, just realized you can't see what I'm doing. I'll give you, once you hit pause so you can copy that. I had combined like terms into this. Multiply by y on both sides. There's my y. Now I'm gonna cancel or simplify. The x's simplify. Actually this x squared plus 1. This is to the 1/2 power, right? These two things I can combine which would leave a 1/2 power in the denominator. So I'm going to end up with y prime. So that'll cancel, leaving a 1/2 power in the denominator. 4x cubed plus 6x squared plus x plus 3 all over 3 times x plus 1 to the 2/3 power, x squared plus 1 to the 1/2 power times x plus 1. Oh, actually, I just see this now too. Those two can be combined. Might as well use every inch of the page I can. The numerator stays the same. The denominator, if I'm multiplying these, then that means I need to add their exponents. So this is x plus 1 to the 5/3 power, x squared plus 1 to the 1/2 power. Finally, circle that, and we're done.